The next topic is multiplication theorem on probability. So we have seen that what is P of E given F. P of E given F is equal to P of E intersection F divided by P of F, provided P of F not equal to 0. So we can write what is P of E intersection F. P of E intersection F is equal to P of E given F into P of F. Okay. The same way, what is P of F given E? P of F given E is equal to P of F intersection E divided by P of E. So what is, and this is same as E intersection F. F intersection E same as E intersection F by P of E. So we can write P of, from the second result, E intersection F is equal to P of F given E into P of E. Okay. So once again I will write that together. So P of E intersection F we can write in two ways, that is, one is P of E into P of F intersection F given E. That is one result. Or I can write P of F into P of E given F. So this is known as multiplication theorem on probability. So from the conditional probability, from that result only we got this P of E intersection F is equal to P of E into P of F given E, or P of F into P of E given F. Okay. Then some examples. Two cards are drawn at random and without replacement from a pack of 52 cards. Find the probability that both cards are black. So two cards are drawn at random and without replacement from a pack of 52 cards. Find the probability that both cards are black. So we are taking two cards, that two cards are black. So we can define event. Let E be the event such that the first card be black. Okay. Now F be the second event, the second card, that is black. So here what we have to find? We have to find the probability that both cards are black. So is the notation is this E intersection F, isn't it? Both cards are black. We need two cards, that two cards are black. We need both. That's why intersection symbol. If either or, you have to use union symbol. Okay. So what is P of E given F by the multiplication theorem on probability? We can write as P of E into P of F given E. Okay. P of E into P of F given E. So P of E, what is P of E? E means the first card is black. We have a box of 52 cards. In that, how many black cards? There are 26 black cards. So what is the probability that the first card be black? There are 26 favorable outcomes by 52. Okay, so it is 1 by 2 or 26 by 52. Now what is F given E? F given E means after A only this F happens. Conditional probability. This occurred first, that is we took already one black card. Now what is the probability that the second card also black? That is the meaning of this, second card also black. Now in that box how many cards are there? Already we took one. So there are only 51 cards, in which how many black cards? Only 25. So the second P of F given is 25 by 52. Okay. So we can write as 26 by 52 into 25 by, 51. 25 by 51. Now we can cancel 26 and 52 cancel. So it is 25 by 110. Okay. Clear this one, and without using this formula also you can find. Okay, we are taking 2 cards from a pack of 52 cards. What is the probability that both the cards are black? So there are 26 black cards. So the first black card, what is the probability of first black card? 26 by 52, and it is without replacement. So now there are only 51 cards and 25 black cards. So just you can write 25 by 51. This is also correct, children. This is using the multiplication theorem on probability. We can write like this. Otherwise, directly you can write, no problem. Understood? And if it is with replacement, then instead of the second number, again with replacement means again there are 26 black cards and 52 cards. So the second number, second probability also the same, 26 by 52. Okay. Now look at the next one. A box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. If all the 3 oranges are good, the box is approved for sale, otherwise it is rejected. Find the probability that a box containing 15 oranges, out of which 12 are good and 3 are bad ones, will be approved for the sale. Okay, so we have a box of oranges. A box of oranges. How we select? The box is approved for the sale? We select only 3 oranges. Okay, without a replacement. If all the 3 oranges are good, the box is approved for the sale. If otherwise, the box is rejected. If all 3 are good, then only the box is approved for the sale. Then in that box, 15 oranges are there. Find the probability that a box containing 15 oranges, out of which 12 are good, 3 are bad, and that box is approved for the sale. We have to find the probability. Find the probability of that a box containing 15 oranges, 12 are good, 3 are bad, will be approved for the sale. So will be approved for the sale means all 3 are good. Then only the box is approved for the sale. So the one method is we can use multiplication theorem on probability. So here we have to define 3 events, E, F and G. E means the first orange. We have to take 3 oranges. So first orange, that is good. First one is good. The second, F means second orange good. Third, G means third orange good. Okay. Now there are 15 oranges in that box. The division is 12 are good and 3 are bad. So we have to take what type of oranges? We have to consider good oranges. Then only the box will be approved for the sale. The question is like this. Find the probability that the box is approved for the sale. So probability. So required probability means probability that the box will be approved for the sale. That only we have to find. So the probability that all the 3 oranges are good. That only we have to consider here. Good. So what about the first orange? What is the probability of first good orange? There are 12 good oranges. So first one is 12 out of 15. And here also without replacement. Check it. Without replacement. So now after taking first orange, now there are only 14 oranges. Out of which how many are good? 11 are good. Okay. Now after that only 13 oranges and 10 are good. So this is the probability. This directly I wrote here. If we use in terms of E, F, G, E intersection F intersection G. Okay. And if we know that what is P of E intersection F? P of E intersection F is equal to P of E into P of F given E. This is multiplication theorem on probability of two events. If three events are there, how to write? This one is E. P of E into P of F given E. Then one more event is there, that is G. G given E intersection F. Okay. Or otherwise we can write P of E into P of F given E. P of F given E means after E only F happen. Then P of G. Then after only G. So G given E intersection F. Instead of intersection symbol, children, we can write like this. EF. That means intersection. Okay. So first we take the first orange, then the second orange. So first one happened. Now the third one. So the first two events already happened. That's the meaning. Okay. So using this, the same way we can write what is the probability of E. The first orange good is 12 out of 15 into F given E. That is only 11 oranges now. 14 total. Now the third one is 10 out of. Okay. Now simplify. This 3, 2, 6, 4, no? Here 2 and 7. 44 by 91. That's the answer. Okay. So without using this formula also you can find. But we have a formula like this, that is known as multiplication theorem on probability. Now the next topic is independent events. Independent event means two events are said to be independent if probability of occurrence of one of them not affected by the other, occurrence of the other. That's the meaning of independent events. They are not depending. For example, consider an example. Consider the experiment of drawing a card from a pack of 52 cards. Okay, so that is the experiment. And let us define two events E and F. E means the drawn card is a spade. The drawn card is a spade. And F means the drawn card is an ace. Okay. So we have to take one card from a pack of 52 cards. E and F are two events. E means the drawn card is spade. The other one is an ace. So what is P of E? How many favorable outcomes? How many spades are there in that packet? There are 13 spades. So 13 out of 52. That is 1 by 4. Now P of F. P of F means how many aces? 4 aces, 4 out of 52, that's equal to 1 by 30. Is there intersection? Intersection means ace of spade. So there is one ace of spade. P of E intersection F is equal to 1 out of 52. Then what is P of E given F? Conditional probability E given F. We can write as E intersection F by P of F. What is P of E intersection F? That is 1 by 52 by F is 4 by 52. So 52 cancel. So it is 1 by 4. And 1 by 4 is same as P of E. So what we can write? P of E given F is equal to P of E. E given F means probability of occurrence of E if F has happened, given that F has happened. F happened first, then only E. But this probability, look this one, The probability of P of E given F and P of E are same. That means E does not depending on this F. Okay. The same way, what is P of F given E? P of F given E means P of F intersection E by P of E. F of F intersection E is same as E intersection F. 1 out of 52 by E is 13 by 52. So it is 1 by 13, that is same as P of F. So here P of F given E is same as P of F. Okay, F given E. So this F does not depending on this E. Here E is not depending on F. So in this experiment we can say that E and F are independent events. E and F are independent. So what do you mean by independent? Two events are said to be independent if probability of occurrence of one of the events is not affected by the occurrence of the other. Such events are known as independent events. So we have one result. That result is P of, if E and F are independent, P of E given F by that multiplication principle, E intersection F we can write as P of E into P of F given E, isn't it? This way, multiplication principle, or we can write P of F into P of E given F. If E and F are independent, what is P of F given E? P of F given E is same as P of E. It does not depending on this, the denominator. Okay, so I can write P of E into P of F. Here also P of F into E given F. If E and F are independent, E given F is same as P of E. That is P of F into P of F. So this result is very important. If E and F are independent events, then P of E intersection F is always equal to P of E into P of F. P of E into P of F. Now, prove that if E and F are independent events, then E and F dash are independent, E dash and F are independent, E dash and F dash are independent. Okay, so we can prove the first one. The same way you can prove everything. So look this figure, Venn diagram, two sets E and F. Then this common portion is E intersection F. This circle is E, this second circle is F, and this portion, okay, E intersection F dash. Here it is E dash intersection F, and outside the circle, that is E complement intersection F complement. We already know all these things. And these four sets are disjoint sets. Now intersection for these four sets, okay, all are independent. Now we have to prove the first one, E and F dash are independent. Since what is given in the question, E and F are independent. Since E and F are independent, we can write P of E intersection F is equal to P of E into P of F. This is given in the question. And what we have to prove? E and F dash are independent. E and F dash are independent means we have to prove E intersection F dash. P of E intersection F dash is equal to P of E into P of F dash. Okay. For that we can use this figure. From this figure we can write E. Look at this E. That circle E is a union of E intersection F dash and E intersection F, isn't it? When we take the union of this portion and this common portion, we get E. Now P of E. What is P of E? So that is equal to P of E intersection F dash. It's a set union. It's an event. In probability we have to say as event. Put a bracket. So now the right hand side in the form P of A union B. P of A union B is P of A plus P of B, then minus P of intersection. What is their intersection? Null set. Okay. Since all the four sets are disjoint, so this part is 0. So we can write P of E intersection F dash plus, and what is P of E intersection F? Since E and F are independent, it is P of E into P of F, and this one is 0. Now take to the left hand side. Here we have P of E minus P of E into P of F. This is F. Okay. P of E intersection F dash. P of E is common. Take outside. P of E into 1 minus P of F. That is P of E intersection F dash. So what is 1 minus P of F? That is same as P of F dash, complementary event. So P of E into P of F dash is equal to, okay, that is P of E intersection F dash is equal to P of E into P of F dash. So what we can conclude? E and F dash are independent. So is it clear? The result is, if E and F are independent, then E and F dash are independent, E dash and F are independent, E dash and F dash are independent. So this is the proof for the first one, E and F dash are independent. Same way you can prove the next two. Okay. So I hope all of you understood this. Thank you.